In today's lecture, we are going to talk about the foundation of an AI. The foundation, the basic where the artificial intelligence has been started. Solving a problem by searching. So there are a lot of searching techniques through which we can solve our problem, because actually the problem is the way that you are going to solve it and the way that you are going to formulate it. And the search strategies, it's totally up to you what and how you're gonna do it in the artificial intelligence. The working of the problem solving agent is always work with you, but the content in which we are going to discuss about is the problem solving agent. What are the agents who can solve the problem, formulating the problems, problem types, examples, and search strategies through which we are going to solve that specific problem. Let's talk about some problem solving agents. So according to the criteria of the definition as the goal-based agent, whatever the problem-based agent is always the goal-based agent. Means to say your problem always has some goals, and to achieve that goal you have to solve the path problem, the problem, anything. So every problem have the initial state through which it can start and the goal to reach the specified goal. Like it's going to be like the very easiest one, that you are going to compete somewhere, and this is your initial state where you are going to start your journey, and there is some kind of the final state where you want to approach, where you want to reach. So this is your final state and this is your initial state where you're going to start your journey. So it always depends on your execution where you are going to lead with these things. So execution, appropriate action, the action between these 2 points to achieve that specific goal. So it depends. So where your initial goal started and where it ends, the final goal. So it's your final destination actually. So this by searching and by the accurate or suitable actions, the sequence and the execution, you can easily reach your final destination. So it depends how you're going to search the specific problem and how you're going to find that word into the problem. So by solving a problem, actually, we are going to consider about some kind of techniques, some kind of research problems, or some kind of the way that you are going to communicate with a lot of things. So before we are going to formulate, so I'm going to start with the A-static algorithm. A-static algorithm means through which we are going to find a search problem and we are going to design the search space. So for that, I'm going to use the Google Colab for the working of it. So let's take towards Google Colab, and I'm going to say the new notebook. And for the new notebook, I'm going to make it name as the A static or A star, because with the help of the problem solving agent, we are going to solve the problem of the search space, where we are going to start and where we are going to end. So for the search space, I'm going to say it A star. Now this is my formulation of the problem. So I'm going to say from Q import, I'm going to import some things, that is heap, pop, and heap push. So there are two things that I need for my criteria, and for this thing I'm going to import from math, I'm going to import some kind of rules, that is information. I'm going to make it run by pressing shift and enter. Now it runs, and now I need to formulate a problem. So I need some kind of graph, some kind of things that I need to communicate or connect with it. So I'm going to make a class that is going to say the graph. I'm going to make a class of a graph, and the function I'm going to define, which is the init object by the Python by default object. And for that part, I'm going to say the self and direct, the directed is equals to true. So which actually go and find and fetch the data what I need. So I'm going to say self.edgeh, where I have put the arrow. This is my edge, and self dot heuristic because I need to find the shortest path for my solution. So I'm going to use the heuristics, and that is also blank. And then self dot directed, which is equals to, I'm going to say another variable that is directed. So it actually technically work with the things that I need to put overall, like this way. If I'm going to start some kind of object from here and the edge, this is the edge, and this is my final destination. Now this is my final destination where I need to reach. Now this is my final destination, and this is my initial state where I'm going to start the problem. So these are the two things which I actually need for this thing to make a graph. And then if my solution is f, and there are a lot of other parts as well in the graph, so I'm going to consider all those graphs as well. If these are the part of the graph, so I'm going to find this one as well. So for that part, I'm going to define another function in which I'm going to say add underscore edge edges, and again I'm going to say the self comma node, so the node 1 if I have, and the node 2, and the cost of every node, that is actually 1 because every node belongs to one cost, and reserved, 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 if there is a reserved node or not, so that's false because we don't have any reserved node right away. Now I'm going to try my neighbors. So try neighboring values, so that is actually called self dot edges edges, and I'm going to collect it from the node 1. So that is actually the basic and the technically the both conditions that is working on the same material. Now if I'm going to try something, then I need to write an exception case, except, so maybe it occurs the keyword error, and that maybe define the neighbor value, and neibgh bor neighbor of the things that not to, which is equals to that cost, the cost of that factorization value, of the cost of that every path that I am working on. So self dot edges edges, which counts from the node 1 and become the part of neighbor of that specific variables. So I'm going to say the neighbor node and the neighbor values. Okay, now if it's not a part of the neighbor, so it's going to say the directed and not underscore crved reserved, so it's not true, then I'm going to add a not, a edge between something from, so I'm going to add edge from node 2 and to node 1 and find the cost of that node, and then true because I have a path, so I'm going to say it's true. And let's change the brackets. It's going to be around brackets. And yes. So what does it mean? It means if I need some other edge, so I'm going to continue with an other edges as well. Whatever I need to connect, wherever I need to connect, and through whatever I need to connect. So it's like this path, and I'm going to calculate the cost of every path that is connected towards the shortest of this heuristic. Okay, now I'm going to, as I said, the shortest towards the heuristic. So why not we're going to make a function that actually counts heuristic values, HURISTI, CS, heuristics. So which counts the heuristic values, that is going to be the self and between the nodes. Self and node, in between that we are going to calculate the heuristic and the values. So I'm going to say the try where, no, not try, I'm going to say self dot HURISTICS heuristics, which is equals to, I'm going to give the variable of heuristic to heuristics. Okay, now I'm going to return the value to the same function at the same time. Now for the graphical, for the neighbor value, if I'm going to consider the neighbor values, NEIGHBOR, if I'm going to consider the neighbor value, that is self dot, again not, okay, I'm going to change this one to HURISTIC heuristic function, because I'm going to calculate the node downside. So I'm going to calculate it as a function where I am going to calculate the value of this heuristic part. And actually, I'm dealing in this algorithm right now, the agent and the working of that agent and the part of the neighboring value. Okay, so by this one, I'm going to say try. I'm going to return the value, which is actually self.edges of what? From the node. And except, again, the key error where it returns nothing. Return nothing. So it will return nothing. When it returns nothing, it means we are going to calculate the cost of this function that we are going to put over it. So it's going to be like self, comma, not 1, comma, not 2. And I'm going to say the try and return the value, which is self.edgs edges, in which I'm going to return something that is more important as a way, as an index, not 1 and not 2. So index of not 1 and not 2, and except I'm not going to make a return of INF. That's it. Now, actually what happened over here is I'm going to I'm calculating the cost of every path here. I'm calculating the cost of every path that happens, every path from 0 to whatever and how many it is. So I'm going to calculate every path, every edge path, where how many distance does it has and how many distance does it calculate. So this is how we're gonna find the way for the heuristic part as well.